In this video, we are going to solve the problem of can place flowers. So the problem statement is, you have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. The most important condition is flowers cannot be planted in adjacent plots. So what are adjacent plots? Adjacent plots are next to each other. In this case, if this is our flower bed, then these two are adjacent plots. Similarly, these two are adjacent plots. So the most important condition is you cannot plant a flower in adjacent plots. That is, if you have planted a flower at this location, then you cannot plant a flower after that location. So what has been given to you? You are given an integer array known as flower bed, where zeros means empty plot and ones means not empty plot. That is, if your flower bed has a 0, you can plant a flower over there. But you must remember that at that location, its adjacent elements should not have any flowers planted. So you are given a flower bed array, zeros indicating there is an empty spot on which you can plant a flower, but adjacent to that location no flower should exist. Ones means a flower has already been planted over there, and you are given an integer n. You are supposed to return true if n flowers can be planted in the given flower bed without violating the no adjacent flowers rule. This is the problem statement. First, let us understand what are adjacent plots. Adjacent plots means they are next to each other. Then the second condition is a flower can be planted at location I if and only if its left and right plots are empty. What should be the condition that handles I equal to 0 and I equal to length minus 1 effectively? That is, if I is 0, that is the first element, then in that case, if you are going to check the condition for I minus 1, your code will not compile because you are trying to access minus 1 index. And if I is equal to the length minus 1, in that case, if you are trying to access the right element, at that time you will get an error out of bound exception. So what condition will handle both when I is equal to 0 and I is equal to length minus 1 effectively? The next question that you should ask yourself is, can we exit the process early? Let us say, in this case, if n is 1, n is equal to 1. So you can plant a flower at this location and then you can exit, right? So what condition will decide that we can exit the process early and mark the solution as complete? The third and the most important question that you should ask yourself is, how many indices to skip after successful planting a flower? Let us say you have planted a flower. Let us say you have planted a flower at I equal to 0. How many places should you skip? The answer is you should skip 2 places, because if these are the values for I, 0, 1, 2, 3, and you have successfully planted a flower at location I equal to 0, then obviously you cannot plant a flower at this location. You can plant a flower at this location provided there is no flower planted adjacent to this location. So, how many indices to skip after successful planting? The answer is you should skip 2 indices. Let me reiterate. Adjacent plots. Adjacent plots means next to each other. A flower can be planted at location I if and only if its left and right plots are empty. We have to define a condition which would handle effectively when I equal to 0 and I equal to length minus 1 in calculating both the left and right plots empty condition. Also we have to check can we exit the process early, and at last how many indices to skip after successful planting. So this is the intuition. Now let us try to develop or write the code for it. So here I have already created a file. Can place flower.js, which accepts a flower bed, which is an array, and an integer n. Then we have to write a program which will check can n flowers be planted into the flower bed. First, let us store the length of flower bed into the variable m. M is equal to flower bed dot length. After that, you will use the variable count is equal to v. Now this count variable will be used to determine our early exit conditions. And then we use the loop variable I equal to 0. We will use a while loop which will go as long as I, we are starting I equal to 0, I is less than n. Okay. However, prior to doing all this calculation, what if what if we are passing an empty flower bed? What if we are passing an empty flower bed? In that case, if m, that is the length of flower bed, if that is equal to 0, then directly return false. Now inside while loop, we have to check where can we plant a flower. We can plant a flower if and only if the value at index I is equal to 0. If and only if the value at index I is equal to 0. So we will add that condition. We will check if flower bed of I is equal to 0. That means a flower can be planted here. However, prior to planting the flower here, we will have to check whether its left and right indices positions are empty. How do we do that? Let us initialize let left empty is equal to, we will use shorthand operators. If I is equal to 0, that means in case of the first element, the left part is always empty. In case of the left element, the left part is always empty. So this condition will handle that. Left empty I double equal to 0 will handle that. Is open enter again. See, the left condition, the element left to index 0 will always be empty. So this condition will handle that. Or we check flower bed of I minus 1 is equal to 0. If either of this condition evaluates to true, then the left spot is empty. Now let us write the condition for right spot. Here, if flower bed of m minus 1 is equal to 0, this is not the case. If flower bed of m minus 1, yes. If flower bed of m minus 1 is equal to 0, then the right spot is empty, or I is equal to m minus 1. In that case also, the right spot is empty. Once we have the left part empty and the right part empty, so we will check if left spot is empty and right spot is empty. Here the flower can be planted, so we increment count with 1. This will be used for early exit. After that, so we have done left. If left is empty and right is empty, we have incremented the count by 1. Okay, so this is done. After this, what should we do? Okay, then we mark the location of flower bed of I equal to 1, saying it has been planted. A flower is planted. Once we do this, then we skip I with 2 places, and then we continue the loop from the beginning. Okay, so if both left spot and right spot is empty, then we increment the count, we mark that position I to be planted, we skip or we move ahead I by 2 places, and we go to the starting of the loop. Out of this if condition, what we are doing is, here we check, not loop mounts. Okay, prior to this continue, what we check, if count is equal to n, that means all flowers are planted, do early exit. So this is happening in case of if both the right and left spots are empty and flower bed of I has an empty spot. What if flower bed of I is not equal to 0? In that case, we just increment the value of I. That is, the loop counter will go to the next value of I and then start processing from there. And from the end of this loop, we return false. So what we have basically done is, let us look at first, this condition ensures a flower can be planted if and only if there is an empty spot. So this condition checks whether there is an empty spot. If yes, it checks whether the left spot is empty and the right spot is empty. If I is equal to 0, left is always empty, and if flower bed of m minus 1 is equal to 0, that means right is always empty. And here, if I is not equal to 0, in that case, we check flower bed of I minus 1. If that is 0, that means right is empty. And here we check flower bed of, it should be m plus 1, because we are checking the right part. And it should be flower bed of I plus 1, not m plus 1. So here we check flower bed of I plus 1. If that is equal to 0, then good. Else, if I is equal to m minus 1. So in my opinion, if I becomes m, so this condition will be first. So we'll write if I double equal to m minus 1 or flower bed of I plus 1 double equal to 0. And then at last, if both left and right spot are empty, increment the count, plant a flower, skip I by 2 places. For early exit, check if count has reached the value of n. If yes, return true, and then continue the loop from the beginning. And if flower bed of I is not equal to 0, then increment the value of I, go to the next spot, Then again start iterating this logic or start executing this logic. So if count has reached n, that means you have planted all the flowers, return true. If the loop has completed and the code has never reached count double equal to n, in that case you return false. Now let us try running this code. I am a bit doubtful at this write empty condition. We'll verify this from LeetCode as well. Let me just run more can these flowers. First we will have to save this file. Problem is 605. Can place, okay, n is not defined. Okay, I haven't passed n. So we should pass the value of n. For this, let us check from LeetCode. The value of n is 1. Here it is. This is the input. And this is the value of n, which is 1. Now coming back to VS Code. So on VS Code, let me pass 1. Save this file. Here. Again, it is showing in is not defined. What? A reference error. Okay, got it. So this statement is failing. Let me just change can plant to output values because n is defined inside the function. Can plant one flower saying, so this is the flower bag. Now it should run. So the answer is true. That means the code is working as expected. Now let us check the failing condition. Here the flower bed remains the same. However, n is equal to 2. However, n is equal to 2. In that case, it should return false. So passing now n is equal to 2, saving the file and running it again. Here it is, it has returned false. So on the left side we have the intuition how to solve this problem, and on the right side we have solved the problem. So thank you all. If you have learned something valuable, please do like, share and subscribe. Thank you.